You're given some information about a block. You're given only the mass and the density. So this should immediately ring a bell that you may need a different equation to solve for the volume. You may want to use your handy density mobile, where volume is equal to mass divided by density. And now you can plug in your values. The mass is 4.1, the density is 4.1, the volume is clearly 1.0 centimeters cubed. Now that we know the volume, it tells us we have to represent the mass and the volume values in a T-chart. We know 0, 0 exists. We also know that 1 centimeter cubed has a mass of 4.1 grams because we just figured that out. And we sort of kind of know that anyway, because if we look at the density, that tells us that 1 centimeter cubed of the stuff has a mass of 4.1 grams. Always remember that in your density value, you have an ordered pair hidden. So now you could double it and then get on with your life. Here's number 2. We see some dimensions here. 3 times 2 is 6. 6 times 4 is 24. That tells us that the volume is 24.0 centimeters cubed. And we are now asked to determine the density of the substance. The mass is 23.0 grams. And using mental math, these are very close to each other. So this is going to come out to be 1.0 grams per centimeter cubed. Now we have mercury. Notice we have grams per milliliter because mercury is a liquid at room temperature. Remember that a milliliter is equal to a centimeter cubed, so we can switch out milliliters and centimeters cubed, and it still means the same thing. It asks you to create a T-chart based on this. Remember that in your density value you have an ordered pair hidden. 0, 0. 1 milliliter has a mass of 13.5 grams. 2, 27.0. Done. 4. 1, 2, 3, 0, 1, 2 centimeters cubed. And now we have our data translated into a line graph. Mass, volume. We have a range on the x-axis from 0 to 2, and then from 0 to about 10. So if I plot my points, over to 1 and up to 5.1, over to 2 and up to 10.2, invisible ruler, and then just for fun, because we love math, we could figure out the slope of this thing, and we would pick this as our first point. Our second point would be this, which would be 2, comma, 10.2. So we rise up 10.2 units, and we run over 2 units. 10.2 divided by 2. 5.1 grams per centimeter cubed is the slope value. Done. Number 5. We see a line graph here, a little tricky to read. We're asked to diagram 1 cubic centimeter of the substance. So I'm going to draw it in 2 dimensions. I'm going to draw a cube that is to scale. I'm going to make dots the same distance apart, and I'm going to make 1 dot equal to 1 gram, and then I'm going to state the density of the substance. So over here we have a bunch of data. It's a little tricky to read, but if you go over to 1, and we can assume that this is volume in cubic centimeters because it always is volume here on the x-axis. I'm going to go over to 1, and I'm going to go up, and I'm going to interpret the value of the center of this diamond, and it's going to be that. So now I'm going to figure out what that is. So that's 2, 4, looks like 5. 1, comma 5. That means 1 centimeter cubed of this stuff has a mass of 5 grams. 5 grams divided by 1 centimeter cubed gives us a density of 5 grams per centimeter cubed. Here's our centimeter cubed. 1, 2, 3, 4, 5. 5 grams, 1 dot per gram, which is not very likely that particles have a mass of a gram. But for the sake of this exercise, it seems to make some sense. Number 6. Here's your mass, here are your volumes. You see that this must be a cube because the lengths are all the same. And we know that 1 times 1 times 1 gives us a volume of 1 centimeter cubed. I should have said 1.0 to be spiffy. 19.5 grams divided by 1.0 centimeters cubed gives us a density of 19.5 grams per centimeter cubed. And now tells us to construct a line graph that shows this substance. We can make this pretty easy. Here's mass, here's volume. Put a 1 right here. And this is very close to 20. So I'll put 20 up here. And I'll put my first point. And I'll go up just below 20. And there's my line graph.